With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so our question is, consider a small surface area of 1 mm square at the top of the mercury drop of radius 4 mm. Okay, find the force exerted on this area by the air above it, by the mercury below it, and by the mercury surface in contact with it. Okay, atmospheric pressure given to us is 1 into 10 raised to power 5 pascal, and the surface tension of the mercury given to us is 0.465 Newton per meter. Neglect the effect of gravity and assume all numbers to be exact. Okay, so we have been given that the surface area at the top of the mercury drop is how much? 1 mm square. Correct. So let us suppose this is our mercury drop. So the area at the top, that is this surface area, is given to us is 1 mm square, having the radius of the drop is 4 mm, and the atmospheric pressure P0 given to us is 10 raised to power 5 pascals, and the surface tension of the mercury is given as 0.465 Newton per meter. Okay, so in the first part we have to calculate the force exerted on the area by the air above it. So the area above it will be exposed to air, so the pressure will be created by the air, atmospheric air. So what we can say is the force exerted on it will be the atmospheric pressure into the surface area. Correct. So the atmospheric pressure given to us is 10 raised to power 5 pascal, and the area is given as 1 mm square, or what we can say is 10 raised to power minus 6 meter square. So from here what we get is 0.1 newtons. Correct. So the area above it will be experiencing a 0.1 Newton magnitude of force. Okay. Now in the second part we have to calculate the force exerted on this area by the mercury below it. Okay, so the mercury below it, we have to calculate the force exerted by this mercury. Okay, so now as we know that the pressure, the excess pressure inside a drop is given as delta P is equals to 2s upon r. Correct. Now from here we can calculate the excess pressure inside the drop as 2 into the surface tension we have given as 0.465 divided by the radius. Radius is given as 4 mm, or what we can say is 4 into 10 raised to minus 3 meters. So from here we can calculate the excess pressure, and it will come as 232.5 Newton per meter square. Okay, so what we can say from here, that the total pressure would be the pressure inside it and the atmospheric pressure. This will be the total pressure. Correct. So it will be 232.5 Newton per meter square plus 10 raised to power 5 Newton pascals, Newton per meter square. Correct. So from here the total pressure comes out to be 232.5 plus 10 raised to power 5 Newton per meter square. So we have calculated the pressure, so we can calculate the force. Since pressure is force per unit area, so force will be pressure into area. Correct. So the total pressure we have calculated as 232.5 plus 10 raised to power 5, and the area is given to us is 1 mm square, or what we can say is 10 raised to power minus 6 meter square. Correct. So from here what we get is the force exerted by the mercury below it, and it will come as 0.10023 newtons. Okay, so the force will be 0.10023 newtons. Okay, now talking about the third case. So we have to calculate in the third part is to find the force exerted on this area by the mercury surface in contact with it. Okay, so the mercury surface in contact with the area has a net pressure equal to the pressure in mercury minus the atmospheric pressure outside, that is the excess pressure inside the drop. Correct. So it will be given as 2s upon r. So the surface tension is given to us is 0.465 upon r, given to us is 4 mm. Correct. So from here we get the surface, we get the pressure as 232.5 Newton per meter square. Correct. So we can calculate the force from here as pressure into area. So pressure is 232.5 Newton per meter square, and the area given to us is 1 mm, or 10 raised to power minus 6 meter square. Correct. So from here we get the force. Correct. So force will come as 0.0023 newtons. Okay, so this much of the force will be experienced by the surface. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.